So we're on page 76 and we're continuing rational expressions and further examples, and the examples we're going to do are 6, 7, and 8. So we start with number 6, and it says add and simplify these two terms. Now you can see here that the denominators are the same. You've got 4x plus 4 and 4x plus 4. When the denominators are same, you can then make one denominator and add the numerators, the numerator term, so x plus 1. Now once you've got this, you can factor out 4 from the denominator. 4 times x gives you 4x, and 4 times plus 1 gives you plus 4. So now you have x plus 1 on the numerator, x plus 1 on the denominator. You cancel this with this, and you're left with a quarter. Number 7, we're asked to subtract right here and simplify these two terms. So the first thing we're going to do is to factor out the denominator on the first term, and there is the number 2 that we can factor out of this, common to both terms. So 2 times x gives me 2x. 2 times minus 2 gives me minus 4. On the denominator here, I can cancel out the, I can factor out the x term. So x is the lowest value here of the lowest power. You've got an x squared here. You've got an x to the 1 here. So you can factor out x to the 1. X times x gives me x squared, and x times minus 2 gives me minus 2x. So now I look at this, and I look at this, and you can see I have a 2. So there's my 2. I have an x. And there's my x, and now I have my x minus 2. So I look for each of the terms here. 2, put that here. X here is unique. And now I've got x minus 2 and x minus 2, so I just put that in once, and that's the lowest common denominator. Now I look at this term, I take this term, and I divide it by that. So just mentally put that, take this, and divide it by that. And what's left over is x, and you're going to multiply this x by x squared. We can show that right over here. Here is the lowest common denominator. Here is the first term, the denominator of the first term. The x minus 2's cancel, the 2's cancel, and I'm left with x. And I multiply this x multiply the numerator by this term x, and that's why I get x squared. Now, when I take this term, and I take this and divide it by this, you can see that I'm going to be left with 2. So 2 times 2 gives me 4. Done it right down here. Here is the lowest common denominator. Here is the denominator in the second term. The x's cancel, the x minus 2's cancel, and I'm left with 2. And that's why I multiply this by 2, and I get 4. Now I have the same common denominator for both. And since the denominators are the same for both, I only have to take the numerators here and say x squared minus 4. Now x squared minus 4 is the difference of squares. It can be factored as x plus 2 and x minus 2. Now I can cancel this x minus 2, top and bottom, and I'm left with x plus 2 over 2x. So, as I said, first of all, you establish the lowest common denominator. Once you do that, you take the lowest common denominator and divide it by the denominator in each of their terms, the residual factor then that you get, you multiply in the numerator. And that's why I multiplied the x by the x squared. In this case, I was left with a 2, so I multiplied the 2 by 2 and I got 4. And then, of course, I collected the terms and factored again and reduced. Now, simplify the complex fraction. It's complex because we have here we have a fraction on the numerator and we also have a fraction on the denominator. So really what we do here, first of all, we get a common denominator here. For 6 and 2 is 6, and 2 goes into 6 3 times, so I get a 3 times 1 right here. 2 goes into 6 3 times, and I multiply the top here. If you look at this, 3 over 6 is really a half. 3 over 6 is a half. So if you want, one of the things you could do is multiply this by 3 and this by 3. Multiply that by 3, multiply that by 3, you got 3 6. Now you have x plus 3 over here. Now the numerator you keep as it is. Now what we're going to do is change the division into a multiplication and flip this term, invert it. So the 6 goes onto the numerator and the x plus 3 goes onto the denominator. I cancel the x plus 3 and the x plus 3. The 3 goes into the 6 2 times, and I'm left with 2x minus 3 because we haven't done anything with that term. Now the other way to do this is to multiply the numerator and denominator by 6. Because if I do that, I'm going to get rid of all the fractions. So we have a 3 here, and we have a 2 here, so you can see, and we have a 6 here. 6 is the lowest common multiple that will get rid of the fraction. So 6 divided by 3 gives me 2. Still have the x squared plus 9. 6 times x over 6 gives me this term, and 6 times plus a half, I've got this term here. So really, in going from here to here, I'm using the distributive rule. Notice that the 6's cancel. I'm left with x. 6 divided by 2 gives me the 3. Over here, the 2 becomes the 2. This is the difference of squares, x plus 3, x minus 3. The x plus 3 cancels, and I get 2 times x minus 3, which is exactly the same as what I've got over there. So that completes page 78 and the examples on rational expressions.